Hello. Today we're gonna be hello everyone. Today we're gonna be talking about Pedro Nunes. Pedro Nunes was a Portuguese mathematician, geographer, professor, and the chief figure in Portuguese nautical science, noted for his studies of the air, including the ocean. Um, we're gonna talk about his early life. He was born in Alcácer do Sal, Portugal, in 1502. His origins are Jewish. Nothing is known of his parents, but there is a certain that they were from a Jewish religion. He studied at University of Salamanca in Spain around 1517. Nunes traveled to Spain because he was born in Portugal to study, although no records exist to prove the date of his admission in Salamanca. At this time, it was typical for boys to enter university at the age of 15. From the wide range of topics that he studied at Salamanca, he must have studied philosophy as well as medicine, mathematics, and geography. In 1523, he graduated, and in the same year, he married a Spanish lady called Guiomar Arias in Salamanca. Pedro and Guiomar had six children, two boys and four girls. We're gonna talk about his teaching. Um, Nunez, after he graduated, in 4 years after he graduated, he returned to Portugal in 1527. He joined the court life and became a tutor of Prince Louis. Prince Louis was the brother of João Piedoso. Joan had become king of Portugal at the age of 19 in 1521. He is known as John III. On December 4th, 1529, he started to teach at Lisbon University as a substitute teacher of moral philosophy. In January 1530, Nunes was appointed to teach logistics. He was still teaching logistics at the university, but it seems that his class was not very popular. So in April, he started to teach metaphysics. He began writing Libro de Algebra in 1534, although only published the complete work 33 years later. Uh, the book the book is in three parts. The first part dealing with equation of first and second degree. The third part dealing with equations of third degree. The middle part of this book studies the theory of proportions and algebraic manipulation. Um, his next published work was the, Corpus- the Corpusculus in 1542, uh, in which he addressed the problem posed by one of his pupils. The question that he posed to Nunez was, which day was the shortest twilight? And it was the question of the duration of the twilight that Nunez addressed in this book, The Crepusculus. Now, the achievement also shows that Nunez was a pioneer in solving maxima and minimum problems, which become a common requirement in the next century using differential calculus. In this image, we can see this is the Libro de Álgebra en Aritmética y Geometría by Pedro Nunes that we were talking about. We're gonna talk about his major work. Pedro Nunes is considered one of the greatest mathematicians of his time, and is best known for his contribution to the technical field of navigation. Much of Nunes' work is related to navigation. He is considered the founder of scientific navigation. Um, Around 1550, he made a discovery for which today he is best known. namely his investigation of the loxodrome. Later, the later investigation of logarithms allowed Leibniz to finish to establish algebraic equations for the loxodrome. In the picture, we can see what is the loxodrome. The loxodrome is also called rhomb lines. Loxodrome curves are directly related to construction of the navigator connection. After Nunes retired from the university, he published a book called Pedro Nunes Salazar's Opera. This book is very, it's a very much extended compilation compilation of Nunes' work about navigation. This book, the Pedro Nunes Salazar's Opera, consists of four texts, well identified in the front page. This book has 308 pages plus 16 unnumbered pages. The third text of the opera is a short essay entitled In Problema Mechanicum Aristotelis, on the movement of boats with oars in the Mechanica of Aristotle. We're going to talk about the instruments and inventions that Nunes did. Nunes did a lot of practical nautical work related to course correction of a ship, as well as to attempt to develop more precise device to determine the position of a ship. We can see in the picture. The picture is the picture of the nautical ring. The nautical ring, it is an interesting and simple proposal of an instrument destined to obtain the height of the sun. Pedro Nunes introduced this instrument in chapter 6 of his book, Pedro Nunes Salazar's Opera. The nautical ring is an instrument suited for solar observations. The ring should be orientated vertical to the sun so the light can come through point G. We can see in the picture the point G is at the top. As Nunes stated, on this instrument, the degree of altitude are twice large as they would be in common astrolabes. In effect, for equal angles, those that have their vertices on the circumference sustain the arcs double in length than those that have a angle at the center. This mathematical property allowed to double the precision of the instrument. The Nunes scale. Nunes devised this graphical procedure as a solution to enhance instruments' precision. The Nunes is a system for taking finer measurements on circular instruments. The Nunes can be included in certain encoders that measure linears and rotational displacement. This device appears in his book, The Crepusculus, published in 1542. In the 16th century, sea navigation still depended on meter astrolabes and other relatively primitive instruments for measuring astronomical altitudes. The precision of this instrument that they were used was greatly limited, and it was limited by graduate scale that they were using. Pedro Nunes created the Nunes to improve the astrolabe accuracy. This consists of a series of circles traced on the astrolabe and divided each one successively with one division less than the outer circle. Um, the Nonius, it's this device that we can see in the picture. This device was created by Nunes later life. On April 25th, he was called back to Lisbon by the King Sebastiano, who had the intention to reinforce the technical formation of seamen. In 1577, Pope Gregory 13 consulted him about the project to reform the calendar, but Nunes died in Coimbra on August 11th, 1578, without advancing much to the project. That's my works cited. I hope you guys learned a little bit about Pedro Nunes and the contribution that he did in the mathematic field. Thank you.